This is number 71, chapter 1. It is looking at density, and the question reads that we have a small airplane that takes on 245 liters of fuel, and the fuel has a density. Remember, D is our symbol for density. The density of that fuel is 0.821 grams per milliliter. What mass of fuel has the airplane taken on? So density is a way to convert between mass and volume. If you have a volume, you can get to its mass. If you have a mass, you can get to its volume using its specific density. And here we have that value of 0.821. But you got to make sure you are in the correct units. We have liters of fuel, but our density is in terms of milliliters, not in terms of liters. So that is our first part here, is to get our given information, the 245 liters, into terms of milliliters. And we can still use our dimensional analysis to do that. We want to turn our liters into milliliters, so we'll set up our dimensional analysis as such. There's 1,000 milliliters for every 1 liter. And if we do that calculation, we get 2.45 times 10 to the 5th milliliters of fuel. So now that we're in terms of milliliters, we can now use our density to cancel out of milliliters and get in terms of grams, convert our volume into a mass. And so we would have our 2.45 times 10 to the 5th milliliters. And I just put that over 1 since there's no units in the denominator. And now I'm going to use my density, 0.821 grams per milliliter, so that my milliliters cancel out and I am left in terms of grams. And when I do that, I get a value of 2.011 times 10 to the 5th grams of fuel. If we were concerned about significant figures, the value would be 2.01 times 10 to the 5th, because our measured value is with 3 significant figures. The rest of the values used in the calculation are known values, absolute known values, and so have no impact on the number of significant figures.